So for C, you're finding the time at which the speed of the particle is 3. So something you need to know beforehand is speed with vectors. So the equation for that in parametrics was the square root of dx over dt squared plus dy over dt squared. And again, we got really lucky because our velocity vectors were given, and that's obviously the derivative. So we already have what we have to plug into this equation. We know that we already are given the speed of the particle is 3, so we know that we can set this equation equal to 3. So we have our square root of dx over dt squared plus dy over dt squared is equal to 3. And then we're going to plug in those points, the xt's, the dx over dt and the dy over dt from a velocity vector that was given in the original problem. Once we plug that into under our square root and we square them, we can simplify down a little bit more to the square root of cosine squared t squared plus e to the t is equal to 3. And then what we're going to do is we're going to go to our calculator and we're going to put this first part, the square root of cosine squared times t squared plus e to the t power equal as our y1, and we're going to set 3 equal to our y2. So just how we did before, we're going to graph this. You want to make sure that the window is between something that you're going to be able to see the intersection point with 3, so maybe like -1 to 4 or something. So make sure you fix that window. And then you're going to click intersect and then get your first curve, second curve, check that off. And then you have your answer as t equals 2.196. And that is where those two, y1 and y2, intersect. And that is where the time at, and that's the time. So part D is asking find the total distance traveled by the particle from time t equals 0 to t equals 1. So the equation you should know beforehand is for the total distance traveled. It's basically the same as the one we used for speed, but you're adding an integral from a to b to put in your time. So you need to kind of know that beforehand. Excuse me. Taking that, you're gonna just plug in what your givens, and like we talked about before, the velocity vector gives you, which is given, gives you your derivative, so you have like nothing to do right there. And you can automatically just plug it into the square root. So like we did before, we kind of simplified that down. We had cosine squared times t squared plus e to the t power dt. And then you want to put your integral in, which is going to be from 0 to 1 because that is what's asked in the problem. So you're going to put that in your calculator. You're going to use the integral in your calculator and obviously replace the t's with x's. And then once you set all of this equal, you should get, for your total distance traveled, 1.595.